Press the bell icon on the YouTube app and never miss another update.
I wish to start a new topic, differentiability and differentiation. Let us take the function y is equal to f of x, and it is defined on closed interval of a comma b. So it is the domain of f of x. Here let us take the coordinate axis, and y equal to f of x. It is the given curve. Next, let capital P be the point on the curve y is equal to f of x. Actually, this P is at x equal to c, just like that. Then P coordinates becomes, means for P, x coordinate is c, y coordinate means by putting x equal to c, y equal to f of c. This is f of c, this is f of c. Next, here on the same curve, let us take at the distance of h, means this distance is h units, then it will become c minus h, that is left side of c or left side of p at the same distance. Here it is also h units, then it will be c plus h, just like that. And let capital Q and capital R be the neighboring points of P on the same curve. Then capital P is c comma f of x, capital Q coordinates are x coordinate c minus h and y coordinate f of c minus h, very clearly, because the function is y is equal to f of x or curve. Next, and capital R is equal to point c plus h comma f of c plus h. So therefore, let the capital P of c comma f of c be a point on the curve y equal to f of x, and suppose Q of c minus h comma f of c minus h and capital R is equal to c plus h comma f of c plus h are the neighboring points on the curve y is equal to f of x. Later we can join like that. Q, it is Q, P, PQ, this is PQ, chord. Next, it is also PR, chord. It is also one chord, PR chord, the chord PR. Here, the slope of PQ bar, means PQ chord, is actually in geometry capital P means first point. It is first point means x1, y1. Next Q, x2, y2. Now the slope of the chord joining the 2 points is formula y2 minus y1 divided by x2 minus x1. So y2 means f of c minus h minus y1 means f of c divided by x2 minus x1, c minus h minus x1 c. Okay, c cancel, then it is f of c minus h minus f of c divided by minus h. So therefore the slope of PQ chord is f of c minus h minus f of c divided by minus h. Remember. So put in the bracket. And similarly the slope of PR bar is same formula, y2 minus y1. It is in geometry. Means that there is a chord joining the points x1 comma y1 and x2 comma y2. Then slope formula is y2 minus y1 divided by x2 minus x1. So using the same formula, P means x1 y1, next letter capital R. Now the capital R coordinates are x2 y2. Applying the same formula, then it remains f of c plus h minus f of y1, f of c divided by x2 minus x1. Here x2 is c plus h minus c cancel, it remains plus h. So the slope of PR bar is f of c plus h minus f of c divided by c. Next, actually there is a curve like that. This is capital Q point. Let it be. This is capital P point. PQ chord will be like that. Next, if Q is moving along with the curve, for example, if Q is here, then the length of the chord will get the minimum like that. Later, as Q tends to P, it will become like that. Finally, as Q tends to capital P, this chord will get its limiting position like that. Limiting position means the chord means PQ bar chord becomes a tangent at capital P. So therefore, what I am telling that, look at the board. As Q tends to P, means what? Q tends to P means it is nothing but h, this distance becoming 0 like that. As Q tends to P, C minus h becomes C like that. Means gradually h becoming 0, means h approaching to 0. That is h approaches to 0, then PQ bar attains its limiting position. That is the chord PQ bar becomes a tangent at capital P. Here capital P is here, so Q is left side of P, R is right side of P. So PQ becomes a tangent at capital P from the left side of P. So therefore now after approaching Q, to P or H approaches to 0, this chord becomes a tangent at capital P. That is from the left side of P. Now, therefore, the slope of the slope of the tangent at capital P within bracket from the left side of P is limit means H approaches to P, H approaches to 0, f of C minus H minus f of C divided by minus H. This is called the slope of the tangent, because as H tends to 0, the PQ bar becomes the tangent. That's why this limiting value is called the slope of the tangent at P, especially that is from left side of P. Okay, this is one side. Next, another side. Similarly, you come here. Similarly, as capital R tends to capital P, that is same. C plus H approaches to, as capital R approaches to capital P along with the curve, means what? C plus H approaches to capital C, means what? Indirectly H approaches to 0. Whenever H becomes 0, then C plus H becomes C plus H becomes C. At the same time, R approaches to R, capital R coincide with capital P, like that. Therefore, as R tends to P, that is H approaches to P, approaches to 0, then the chord means capital P R bar attains means this chord attains its limiting position. Its limiting position. Attaining its limiting position means what? PR bar becomes the tangent. The tangent becomes the tangent at capital P, that is from within bracket from the right side of capital P, right side of capital P. Means what? Suppose it is like that. Just I am considering separately this part, right part. What I am telling that capital P is C comma f of C, and capital R is C plus H comma f of C plus H, like that. As H tends to 0 means R will approaches to capital P along with the curve, like that. First position, next position will be like that, next position will be like that, next position will be like that. This process is called attaining its limiting position. Means ultimately R will coincide with capital P. Then this graph will becomes like that. Means it is called attaining the limiting position, the chord. Okay. So it is happening from right side of capital P. So therefore, as a limiter H tends to 0, PR bar slope is what? F of C plus H minus f of C divided by H. It is the slope of the tangent, slope of the tangent, slope of the tangent at capital P, that is from the right side, of capital P, that is from right side of the capital P. Now at present we are having for one curve at a point capital P. Suppose it is the tangent like that, right side it is capital P like that, but on the curve y is equal to one basic point is there. Y is equal to f of x is a given curve. P is the unique point. You can take any curve. If there exists one point like that capital P, we can draw only one tangent like that. Means at a point capital P, for the curve y is equal to f of x, there will be unique tangent. We can draw only one tangent at a point capital P, while capital P is one point on the curve y is equal to f of x. So this is the hypothesis, universal truth. But here we are having two kinds of values. Means from the left side of P it has one slope, and from the right side of P it has another value like that. So therefore this is also the slope of the tangent at the capital P. Catch my point. It is the slope of the tangent at P. It is also slope of the tangent at capital P. Same point. But at a point, at only one point, we are having only one tangent. Every tangent will have only one slope value. So therefore, definitely these two will be the same. So therefore, what I am telling that for any curve, at a point, means at one point, at a point there exists unique tangent, and it has unique slope within bracket if exists means if this value exists, and if this value exists, if it is possible to find this value, that is what I am telling. So therefore, for any curve, you can take any curve. If exists P at a point, at only one point, there exists only one tangent, will be like that. For one tangent, it will have unique or only one slope value. Therefore, for any curve at a point, there exists unique tangent and it has unique slope. This is the fundamental or universal truth. So therefore, according to this hypothesis, we are having this value. Means what? Limit h tends to 0, f of c minus h minus f of c divided by minus h is equal to or same as second value. Limit h tends to 0, f of c plus h minus f of c divided by h. Remember these two values. Okay. So therefore, for y equal to f of x, this is the given curve. Its domain is closed interval of a comma b. Suppose capital P is any point on it, and capital Q comma capital R are neighboring points on the same curve. Then this limit value equal to same as this limit value. Okay. Next, further. Actually, this value means left hand side value. This value is called left differential left differential coefficient. This left value is called left differential coefficient, simply LDC, and it is denoted by F dash C minus, just like that. C is what we are discussing at point C. C minus means minus stands for the direction left side, and this value is denoted by just F dash C minus. Next, you come here. This value, right value, this limiting value, it is called right differential coefficient, simply RDC. It is denoted by F dash of C plus. C means at a point C, Next, plus means stands for right side direction, F dash of C. Or in other words, it is called as right hand derivative or right hand differential coefficient. This is called LHD. These are notations, meanings. LHD, left hand derivative. This value is called LHD, left hand derivative or left differential coefficient. And notations, F dash of C minus, here right differential coefficient, RHD, right hand differential coefficient, F dash of C plus. So therefore, you come here. So, if LHD is equal to RHD, means left limiting value is equal to left hand derivative is equal to right hand derivative, then that by implies y is equal to f of x is called differentiable function. Differentiable function. So therefore, if LHD is equal to RHD, both limits, if exist, it is to be understood. If both values are same, then only it is called as a differentiable function. Otherwise, that is LHD is not equal to RHD, then f of x is called, non-differentiable function. So therefore, these are the limiting value and some notations, meanings. So therefore, differentiability means that it is it can be determined with the help of limits value. So therefore, first we must be perfect in finding the limiting values. So therefore, my sincere advice is, before reading this topic, it is better to revise limits topic. So we must know that how to find for the different limiting points for the different functions. Okay, next. So this is called differentiability or non-differentiability. Next, actually here we said f dash of C minus means what? Limit h tends to 0, f of C minus h minus f of C divided by minus h, and we said f dash of C plus that is equal to limit h tends to 0 f of c plus h minus f of c divided by h. Here we are having two limiting values, namely this and this. So therefore the process of finding these limiting values is called the differentiation. Means differentiation means it is only the process. The process of finding these two limiting values is called the differentiation. Okay. In general, at x equal to a, we can discuss the differentiability of the given function. For example, at x equal to a. So therefore, at x equal to a, LHD, left hand derivative, is equal to notation f dash of a minus, that is equal to limit according to this. Just we are writing small a instead of c. So h tends to 0, f of a minus h minus f of a divided by minus h, and RHD at x equal to a is equal to notation f dash of a plus, that is equal to limit h tends to 0, f of a plus h minus f of a divided by h. Okay, of course already I said if f dash of a minus equal to f dash of a plus, then f is said to be differentiable. Differentiable function at x equals to a. Otherwise, it is called as non-differentiable function. Means if f dash of a minus, mind it, minus stands for the direction only, means reading for left. Next, not equal to f dash of a plus, then f is non-differentiable function at x equals to a. Later you look at the if f dash of a minus is equal to f dash of a plus, then only f is differentiable function at x equals to a. Then that by implies extends to a, f of x minus f of a divided by x minus a. Means what? If f of x is differentiable at x equals to a, then f dash of a is equal to limit x tends to a, f of x minus f of a divided by x minus a. Understand? Next, in general, we can write at x, f dash of x means limit h tends to, it is generalization. It is at a particular point, but it is at x. So limit h tends to 0, f of x plus h minus f of x divided by h. It is also one of the formula or definition. Actually, this is called the first principle. The first principle of derivative. The first principle of derivatives. So the first principle of derivative means f dash of x equal to limit h tends to 0, f of x plus h minus f of x divided by h. Actually, the given curve is y is equal to f of x. Derivative of derivative of f of x with respect to x variable with respect to x is denoted by here we are learning some notations denoted by y dash or we can write dy by dx. Means what? D by dx of y, differentiation of y with respect to x, like that. Or simply f dash of x or d by dx of f of x, like that. Or we can write y suffix 1. These are the beautiful notations for the derivative of f of x with respect to x. This is called first principle. It is called derivative of f of x at x equal to a. This is called left hand derivative, means with the limits. This is called left hand derivative. This is called right hand derivative, LHD and RHD. If LHD is equal to RHD, then only we can say that f is a differentiable function at x equal to a. Otherwise, it is called as non-differentiable function at x equal to a.